Okay, let's start. Let's move on to our main event. This is Rod Brown Day because not only is he doing What's Up, he's doing our lecture. And as you know, it has to do with basic telescope use. But let me read uh, this blurb about Rod. I copied and pasted this right before leaving, so I'm reading it de novo.
And I wrote it.
He wrote it. I mean, press is pretty good. Listen to this. Yeah, he's good at this, right? So, Rod grew up at the edge of a suburb of Lima, Ohio. Lima?
That's in the beat.
Okay. That is in Peru.
That
Okay.
is Peru.
10 miles north of Neil Armstrong's hometown of Wapakoneta. Hey, I got it right.
Yeah.
Ohio. He watched the moon landings as a small child and regularly visited the Neil Armstrong Air and Space Museum that was built nearby. But he always took for granted the Milky Way that was in the sky each night. How many of you grew up in a big city? The only Milky Way I knew was the candy bar, right? Right? One summer, he and a friend made a haphazard attempt to learn the constellations, and shortly after graduating from high school, he observed a partial solar eclipse. Hopefully, you're using what do you call them? Glasses, right? Okay, yeah. However, his interest in astronomy largely stayed latent while he attended MIT, graduated with a degree in physics with electrical engineering, served as a naval officer for 5 years, moved to California to get a master's degree at Stanford, and worked in Silicon Valley at HP and Cisco. His primary passion at the time was mountain biking. You'd think it was like science or something, this way this read. And mountain biking, and he spent many evenings and weekends exploring trails in the Bay Area and across Northern California. Probably got to see a little bit of sky during that time. When he had the opportunity to move to Nevada City and work at the Grass Valley Group, he jumped at the chance to be near the foothills writing. He jumped at the chance to be near the foothills writing, which is he still loves, something like that.
Yeah, right.
And after another master's degree and a career change, a couple years ago he started reducing his work hours and found the time to explore his latent interest in astronomy in the darker skies here that were harder to find where he lived in the Bay Area. He joined the Nevada County Astronomers 1 year ago, and Rod has been a blessing. This is very understated because Rod was also a project manager, and we were in dire need, not only for a treasurer and secretary, but a project manager, because we'd meet in board meetings, and it was like, what did we say last month? What are we keeping track of? And our first meeting with Rod over some brews, he was taking notes. I'm like, what is he doing? An hour later, he had like this agenda, like all the things we talked about, who was supposed to do what. I'm like, boy, none of us were doing that. So, let's thank Rod. Anyway, let's welcome him.
Great. That's great.
Great.
So tonight's presentation, I called it the Quick Start Guide to Observing the Night Sky. And if you've ever had any of these questions, I won't read them off here, but basic things like, what should I use? Where should I go? What should I look for? How can I get started? How can I get better? This presentation's for you. So first, how did we get here, and how did this presentation come to be? So I'm not going to read through all these details, but it took me a long time to get to this point. You can say it started back in 1974 when I was a kid, and I got a subscription to Astronomy magazine for the first time. That was back when it was all white with one beautiful picture on the cover. I don't know if anybody remembers those years, but it was a very elegant magazine at the time. Not that I appreciated that when I was 8 years old. 10 years later, I had a good friend of mine. We went out and tried to learn some of the constellations. Then, 13 years after that, when Hale Bopp was around and I was living in the Bay Area at the time, a friend had a very cheap, very heavy telescope. We went backpacking. I think I carried this big, heavy wooden tripod in the backpack, and he carried the telescope tube itself. And we went to Henry Coe State Park, if anybody knows that, down in the Bay Area. Beautiful park. Mentioned mountain biking. I spent hours and hours and hours there, mountain biking, beautiful place. But anyway, that was pretty cool. Got to see that telescope, but really nothing much more happened after that until March of 2022. This same friend who I'd known since high school, he was getting rid of the telescope. I bought it from him, and it was almost sort of accidentally. I wouldn't have gotten it unless he was selling it. A couple of months later, another good friend of mine, we went to the Golden State Star Party. If you've never been to that, it's pretty spectacular up in Northern California. I know Bill's been there. Has anybody else in the room been up to GSSP? I know Paul's been there. He's not here tonight, though. We really should go sometime. Beautiful dark skies. Yeah, I've been doing this for a few months at best. I was still figuring stuff out. Sometimes I found things, sometimes I didn't. Probably more often I didn't. But I had that sort of enticement of starting to find some things. So really for the next year and a half or so, I messed around with the telescope now and then, but didn't really, use it that often. I bought different accessories, thought this would be cool, thought that would be cool. Some stuff was useful, some stuff wasn't. Sometimes everything worked. It was really exciting. Other times I just got really frustrated. Finally, this was just last year, spring of last year. I found this book, The Next Star User's Guide, and I read the effing manual cover to cover. And I also found people online who told me some things about the telescope that weren't in the manual or any of the manuals. And based on all that, putting it together, I started having consistent success. I was finding things every time. I was getting good alignments every time. I was really having a good time. Right around the same time, I was watching Craigslist for stuff, and I found this deal on some eyepieces, and they were really expensive. And I watched it for weeks and weeks, and I talked to a friend of mine, and he said, "That's a really good deal. You really should get them." Well, they were over in Reno. It ended up like snowing the night before. Had to wait for the roads to open. Went over there, finally bought the eyepiece and brought it back, and it was like, it just blew my mind away how much that improved my viewing. And pretty much at that point, I was hooked. And then I went to the GSSP at the beginning of July last year and realized that I wanted more. So that's really where the hook got set in me.
What does that stand for, GSS?
The Golden State Star Party. It is probably the biggest and most one of the star parties, the darkest skies in California. It's up north, almost all the way to it's at the north end of Siskiyou County, essentially, on a ranch in the middle of nowhere. So anyway, July of last year, the weekend we were supposed to have the Plumas Eureka Star Party. We didn't have it. I ended up driving to Huntington Beach to pick up this telescope. It was a good deal. And I was very happy with that purchase. I still love that telescope. And pretty much from that point on, I started going out as much as I could. I learned what I liked and what I didn't like. I learned what worked for me and didn't work for me. I started taking notes. That was a really key thing. I started writing down what works and didn't work for me. And I bought a few things that I realized would help my viewing based on my research. I also sold a whole bunch of stuff that I realized I didn't need. So these days, I continue to record my observations. Occasionally I tweak this for that, but I'm not really buying stuff anymore. I'm really spending my time figuring out what to observe. I try to go out as much as possible. So here's my point. Don't be like me. Skip that first 2 years that I did of just sort of futzing around and not really knowing what's going on. Use this guide tonight to help you avoid everything that I did wrong. If you're getting frustrated, ask for help. Really ask for help. We'll get into that more as we go through here. And if anything, please keep at it. And if you take away nothing else tonight, just go out and observe. I want to get that up front, and you'll hear it about 3 times more through this presentation. So with that, how do you get started? Well, you don't need very much to get started at all. Enjoy the night sky with whatever you have. We were just talking about, you were talking about being out in a sailboat in the middle of the ocean and just looking up. I mean, that would be mind-blowing. There's nothing around. And no lights. That's all you really need is your eyes to look up the sky. And if you've got a planisphere, those wheels, I meant to bring mine, but I forgot to bring it. I have a picture later on in here. Bring that planisphere with you. It's a great way to get started out there, and you can do so much. just being out there and enjoying the sky and looking at what's up there and figuring out where things are. So much fun. Binoculars. You don't need special astronomical binoculars. If you've got just a decent pair of binoculars that focus on infinity, interestingly, not all binoculars focus on infinity. I learned this the hard way too. Most do though. If they're just decent with a decent field of view, bring them out. I use the ones that I bought to watch my daughter's rugby games. They work great. Take those out, and you'll be amazed at even how much more you see with those. So the very first line there, your eyes in the planisphere, that's enough. If you got binoculars, great. You could spend, I mean, there are whole books written about binocular astronomy. That's enough to do a whole bunch. If you're interested, you can go farther. Small telescope. You see that small 90 millimeter telescope over there. That's a great one to start with too. With that, you can see the moon. If you look at the moon with binoculars or a small telescope, amazing the amount of detail you can see on there. And you can look at it through the different phases and see a whole bunch of stuff. You can look at the planets. You can see Jupiter. You can see the bands on Jupiter. You can see the moons of Jupiter. You can see the rings on Saturn. There's so much you can do with that. You can also start to see some of those objects that I mentioned before in the What's Up presentation that I gave. With a medium telescope, you can start to get more deep sky objects, and you can get greater useful magnification and see things in more detail. You can keep going as far as you want to go. Eventually, you can see. The bigger you get, you can see more and more fainter things because you'll gather light. You'll hit a magnification limit, but that's not necessarily super relevant. The biggest trade-off, though, is that the bigger you get, the heavier you get, and it's harder to take out. The best telescope is useless if it never gets used. So figure out what works for you. Start small. Keep it handy. Keep it easy, and keep going that way. So that brings us to what I call Brown's first law of observing. You'll get better at observing faster by going out with nothing but your eyes in a notebook than by staying at home with a telescope in your garage. The whole key is to get outside. And the corollary of that Brown's law is you'll have more fun too. Just get out there. All right, other things to bring. Be comfortable. That's the first rule. It gets cool at night. If you're in midsummer, like last year at the Golden State Star Party, it was 100 plus during the day. The nights got down to the 70s. You didn't need much, but most of the time you need something. Layers are great. Warm pants, a hat. If you're like me, you have no useful insulation on your head. 2 hats are useful. Gloves. I love these gloves. These are like less than $20 on Amazon. They got the little grippy things on the pads. They've also got the smart touch phone sensitive fingertip things. They work great. Are they perfect? No, but they keep your hands warm and you don't drop things, and that works great. Bug repellent. The bugs can be out there. Bring your DEET or off, or I use one of those little thermocell things that generate a little cloud of stuff that keeps the bugs away. A comfortable chair. You're going to be sitting out there for a while. You want to look up the sky, bring a comfortable chair. Drinks and snacks. I don't know. At the end of this, though, I have a whole bunch of links, and I will send that out to the email. I'll send those links out to the email list, and you can find everything there. You're welcome. Other stuff to bring. Now we get into the astronomy specific gear. A planisphere. This is a planisphere. This is a big one. There's small ones too. I like this big one because you can see everything together on one side. Some of them you have to flip back and forth, but any of them are good. Something else to navigate this guy with. The planisphere to start, but there's a lot of great apps out there like Stellarium. It's free. You can use that on your phone. You can point it around at the sky and see what you're looking at. You can also use the Star Atlas. There's free ones online. Again, I'll have links to all that stuff out there. Or you can get a book that shows the night sky too. A notebook and a pen. Like if you start taking notes, you'll start to learn what works for you and what doesn't work. And I think it also deepens the appreciation. We'll get into that more as we go through here. Red flashlight. I have a lot more on red flashlight, so hold on to that. Binoculars we already mentioned. And if you're a person who uses glasses like I do, and I like to observe with my glasses off, so I keep my glasses on the strap because I'm always popping them on and off. find it very happy to have that handy. So you're never like, where did I put my glasses?
Yeah.
All right. Now we get into other stuff. So now, if you decide to get a telescope, you're going to bring the telescope. It's going to be on a mount, and most of them will have a tripod as well. You'll have eyepieces. There'll be other accessories that go with that potentially. It could be cables and batteries and spares. A table is super handy. It keeps your gear at hand. You can sit everything on top of it. It also keeps everything out of the dirt, which is nice. In some areas, not so much around here. Certain times in the winter, you do have to worry about moisture. When the temperature gets close to the dew point, a lot of telescopes will have, you can get dew shields for them. It can be very simple, just a cylinder of material that essentially extends out beyond the front objective of it, basically keeps the dew from forming on it. Very simple way to do it. If you're at home, you can use a hair dryer if you're out on your deck or something like that, just in a low setting to gently dry the moisture on there. You can also get dew heaters and stuff like that. How do you bring all this stuff? I find bins, stuff sacks, and cable ties, as I put it here. Bins are great because they keep everything together and they keep it ready. If everything is ready and all you have to do is pick up that bin and put it in the car, you're more likely to go out than you have to figure out where everything is. Organization also makes things easier to find. If you see, there are two bins. The top one I have is all the stuff that's specific to one of my telescopes. And the bottom bin there is the stuff that I use every time I go out, no matter what telescope I'm taking. I still have two telescopes. So having everything together makes it easy. The other thing that I do is when I come back, I charge all my batteries and make sure I put them away charged so that, again, you don't have to worry about, oh, I want to go out tonight, but I didn't charge the batteries. Put stuff away with the batteries charged. All right, where to observe? The best place to start, as long as you're not in, downtown San Francisco or something like that, you've got a view of the sky, you can get started in your backyard. It's a great place to start. It's an easy place to be, especially if you forget something. You can go back inside. You can get it. If you need new batteries, you can go inside and get those. It's also great if you got limited time to observe. It's very easy to walk outside, do things. You can even, set your stuff up. And if you're in the right space, a lot of folks here live out in the country somewhere. You can leave stuff out on your deck and just use it then. And that's a great place. Even if it's not that dark, you'll be able to look at the moon and see all the detail on the moon and the planets as well. And depending on where you are, you might be able to see many of the Messier objects as well. Once you sort of get used to things in your backyard and get some practice there, look at going to some darker spots outside of town. The place where Al has the star parties at the new moon every month is just over here at the corner of Old Brownieville and State Route 49. It can be a little busy there with folks going by, but it's pretty close to town and easy to get to. Another place that folks I go to regularly, and other folks have gone as well and met me out there, is the Washington Road Scenic Overlook. If you go up 20 and go north on the road that drops down into the little town of Washington, about 1.25 miles or so down that road, you get to a white spot, and there's even a sign that says Scenic Overlook. Right there next to the road, there's a big open spot. It's old hydraulic mining site, essentially, and stuff's been flattened out. There's pretty open views. There's still some trees around, but it's relatively open, especially for being in the area. It's also on the north side of the ridge, so light from other areas gets blocked off. It's a nice spot to look. I also go up on the plateau, and other folks have been up there as well on the west side. That gets you up a bit. It blocks the lights from the headlights of the cars going by. It's a very great place to look. Just about 20 minutes from Nevada City here. There's other spots folks like to go to as well. I know, Nathan, you've talked about going to someplace out on 80. I can't remember the name of that spot. You've talked about it before, but I can't remember the name. Anyway, there's other places around too. Another great opportunity is going to star parties. We have these monthly star parties. We try to have them. Hopefully the weather will be good again and we can have them. Come out and bring your telescope, bring your gear, learn from other folks. share the views with folks who show up, look through other people's telescopes. It's a great way to learn and to have fun. Sky conditions. You'll want to know, what things are going to be like if it's worth going out and looking at things. A key thing is the sunrise and sunset time. Lots of places to look at. The sources that I'm here will have sort of all these things in one place. The moon phase, rise and set times. I mean, the moon, it's best to look at the dimmer objects when it's a new moon, when you don't have that bright moon shining in the sky and sort of drowning out the other things. But if you want to look at the moon itself, there are different things that you can see as sort of the Terminator moves across the moon, and you can the shadows bring different details into light, into relief as well. Weather is key. Clouds, temperature, and dew point. Those are all things that you want to consider. There's a couple specific astronomical terms that we talk about as well. Seeing, you'll read about, can be good to bad, and that refers to how steady the air is. If you look up the sky and look at an object and it's all quivering and shaking, that's bad seeing. That's just the different air currents moving around and making things look very essentially blurry. When we had that moon occultation of Mars, I went up to Washington Road to look, and the seeing was like the worst I'd ever seen it. The moon was like a boiling glass of milk. It was just like, it looked like it was frothing, and then this little bubble of the Mars sort of popped off of that. It was unfortunate, but it was still saw it. So that's one aspect that we often talk about. Another one is transparency, and that has to do with just the fine particles, essentially, like from smoke and things like that. That it's not so much clouds, the water vapor sorts of things. It's other things that are in the air that can obscure things as well. Another thing is light pollution. That doesn't change much, but if you're in a darker spot, obviously you'll be able to see more than if you're in a brighter spot. There's lots of sources. Again, I'll have links for these things. I'd say the three main ones that I found to be useful are Clear Dark Sky. They have forecasts for different areas, including Washington Road. Astrospheric. I got a little screenshot of that there. Basically, you can pick out a place on the map, and it will give you the forecast for there. And each of these lines that you see down here is one different thing. One has to do with seeing, one has to do with transparency, and one has to do with clouds. I think I might have mixed up the order there, but those are the three key factors that they show by hour how good they are. Where white is bad, think of it as cloudy, and dark blue is the best. So if all these three things are dark, you've got really good conditions.
Is this predictive, or is it?
It's predictive. It is predictive, exactly. So they look at different weather forecasts and other atmospheric characteristics, predict out for the next few days what the conditions will be. This site also has things down here like essentially I think that's the wind forecast, and down here you can see the prediction of the temperature and dew point. So like in this area where they get close together, you've got good potential for dew to form, and you'll have to plan accordingly. This also shows the moon rise and moon set. You can see the arcs there, and then the sunrise and sunset as well. So you've got all that information in one spot. Astrospheric. You can Google it and it will come up. I will also send out all these links later. Clear Outside is another one, very similar information. And a light pollution map is just what it sounds like. It's a map of light pollution worldwide, and it's a useful thing to look at too. Okay, so now we've talked about what, we talked about where, we talked about what we're going to observe with, we talked about where we're going to observe, we talked about are the conditions going to be good. Now it's like, what itself will you look at in the sky? And this is how you can figure out what to do there. So there are things, we did what's up. Greg talked about different things that he talks every month about, different things that happen at different nights. There are lots of magazines, apps, and other resources that will help you do that. And again, I'll send you all these links. There are good books for other things. So we'll get into a little bit about how to find things like there are books that will give you all sorts of guides in the night sky. A great beginner's one that I like is Turn Left at Orion. It really walks you through how to find different objects in the sky. There's all sorts of lists online too. There's catalogs on the Messier objects. So the Messier objects were 110 plus minus, depending on how you count, objects that a astronomer in the 19th century, 18th century made a list of because he was out hunting for comets. He kept running into these things that weren't comets. They were galaxies and they were nebula and things like that. So he made a list of those so he didn't get them mixed up with comets. Well, now that's a great list that we all start with and go out and specifically look for all those things. They're beautiful objects. You can find different lists of seasonal highlights, like best things to see in the spring and things like that. All sorts of magazine articles, all sorts of lists. Other things are star atlases. You can get ones like this, the Jumbo Pocket Sky Atlas. Seems to be a bit of a jumbo pocket. I guess you have to have a very large pocket. Yeah. There are so many resources online. Freestarcharts.com is exactly that. You go to that website, there's free star charts. You can print out, download and print out PDFs of things. There's all sorts of sky atlases, including many classic ones that you can purchase. And I mentioned Stellarium before. Stellarium is an app, but it's also software, and I have a screenshot of that coming up. Or Sky Safari. Those apps are very useful for finding things too. Maybe when you get more advanced, you can use software too. I like to use Astro Planner. It helps me make lists of things that I do as well, that I use as well. I mentioned Stellarium. Greg's used Stellarium in our meetings before. Again, free program. You can download it onto your Mac or your PC, and you can set the location, date, and time. And it will show you what's in the sky, and you can also set it up. You can give it the details of your telescope and your eyepiece, and it will simulate, what you will see with that combination of things. Here I got the, let's see, this, I guess I took this screenshot back in March, but this is essentially what the sky would look like on March 27th at 9:27 p.m. And that's obviously the double cluster in Perseus that we're looking at there. And it's over here, can't read it here, but it's got all the details, the magnitude of the object, the coordinates of the object. We won't get into coordinates today, but we'll talk more about that in a future presentation, rising and setting times and all those sorts of things. Free program, great thing to use. And you can start off simply and add on more and more. Lots of great stuff there. Okay, we figured out what we need, what we're going to look at, where we're going to go. So how do you get ready? Practice at home. It's a lot easier to figure out things at home during the day than at night for the first time. Make a checklist, make a list of stuff that you're going to bring, make a list of how you're going to set things up. Align your finder. So the telescopes over there, both of them have optical finders on the tube. The small one on the right there has a Rigel quick finder. Those are great useful aids that you will use, and we'll talk about how to use those in a second, but you'll need to adjust those during the day. You'll want to set that up, put them up pointing at the top of a tree or a flagpole or at some distance or something like that, and make sure that you align those such that when you look through the telescope, what you see centered in the eyepiece is centered in the finder as well, and there's little adjustment knobs on there to do that. Start early. Pack your car early when it's still light. Plan to arrive early, well before sunset, so you can set up everything while it's still light and figure out, especially those early times, what I do, what I need to do. It's a lot easier if it's light out. Okay, that gets us to Brown's second law of observing. Preparing your clothing, your gear, and what you'll observe ahead of time will make your observing session easier and more fun. And there are 3 corollaries to this law. Number 1, being cold or mosquito bitten is not fun. A power cable left in the garage is useless. And I found it is more fun to say than, what can I see now? Okay, you're there. You're setting up. Here's Greg setting up at one of our times out at Washington Road. So you get there, pick your spot. You just note the directions, so figure out which way is north, etc. Look for clear horizons. You might be able to move a little bit one way or another if there's something particular that you want to look at and it's going to be in your direction. Like, for example, last fall when the comet was in the sky, I went out and figured out where the comet was going to be and realized I needed to position myself between a couple trees, to catch it as it was setting in the west. If you happen to be near street lights or other houses, try to set up to block those lights. If you're at home, maybe you can set up a tarp, to block out your neighbor or ask them to turn off their lights or something like that. Set up your gear, assemble and test everything out. Check that finder alignment. We talked about aligning the finder before. You can do some fine tuning on that when you're out there, or if something got bumped or something like that. Set up your table and lay out your gear. Another key thing is starting to plan to keep things dark. So figure out before it gets dark how to turn off your car's lights, and both interior and exterior. You don't want things flashing or coming on bright, and we'll get into those details here shortly. And if you get there early and you're all ready to go and start day, not dark yet, enjoy it. The sun's going to go down. You'll start to see different things come out. You'll hear different creatures. Just enjoy the sunset. All right. The key thing here is protecting your night vision. Bright lights are not good. It can take 30 minutes or longer for your eyes to adjust, for your pupils to close down, and for the chemicals within your eye to regenerate, to make your eyes sensitive again to dim light. And red lights are better, but they're not perfect. A bright red light can also affect your eyes, and it takes about 10 minutes to recover from a bright red light, and that's what the curves here are showing. This first one, it's hard to see, I know, but this is a 30-minute point. There's a couple different factors affecting the sensitivity of your eyes, and that's what that's showing there. And the lower one is the red light. So the key thing is no white lights. I have that capital letters, you might have noticed. And in orange too. That means from your flashlight, from your car, from your phone or your tablet or any other devices that you have out there, including your laptop. You don't want any bright white lights. Also be careful with red lights. Keep the light as dim as possible, and be careful. You're using a lot of people like headlamps. It's great because you can use your hand, but you have to be careful with that. If it's bright and somebody said something to you and you go and point it at them, you can shine it right in their eyes, which is not good. So be very careful about that too. So,
what does it take to mess up your vision, to get hit with a flashlight?
oh, how long does it take for it to go bad? It's pretty quick. Slam your eyes closed if you can. But I don't know. I'd say it's probably less than a second or two. It's pretty quick. That's a good question. I might have to look that up later. All right. So, like I said, use a dimmable red only flashlight. And that means it's very tempting. There's a lot of them out there. There are lights that you press one button and it'll cycle through white and then to red and then eventually to off. Well, there's an inherent problem with that because you always got to go through white. And that's bad. Even some of them, sometimes they'll have a separate button for white. That's also bad because you're up here feeling on your head and you inevitably press the wrong button. So don't use a light that has white on it. Just please don't. Really, please don't. The best lights, and this is a little bit trickier because unfortunately the best lights, there's only a few out there that are really good. They have a dimmer knob. Most lights have like a button that you press multiple times and it goes through different steps to get dim. The only one that I found is this one right here. And this one's Celestron branded, but there's one company in China that makes them with all sorts of labels on them. This one's got, you can see this little knob up here, and it's great. You just turn it on and you can adjust it and keep it very dim. That's the best one I found so far. The other advantage of that, it's handheld. like I mentioned before, if you got a headlamp, it's very easy to accidentally shine it in someone's eyes. It's harder to do that with a handheld flashlight. I found that some lights are too bright, even on their dimmest settings. This stuff here called Dim It, I bought this stuff years ago. I had a clock that had bright LEDs on it that were too bright, and I found this. It's basically this smoked film. It's just plastic, and it sticks to stuff. I have it. We have our internet router in our living room has these bright lights on. I put that on there too. It dims all those LEDs. I use it on all sorts of stuff. It really it keeps the color, but it makes all these lights less bright. It's really good stuff, and it's really cheap. You can get it on Amazon. And there's another brand too. I can't remember what it's called, but there's a number of the same things. This again, just this plastic film that's sort of heavily smoked color that works well. Make your electronic screens red. A lot of apps that you use have a night vision setting, and that'll make the screen red. And you can also do things, and again, I'll have links in here to it. You can make your whole phone turn red so that the other colors are essentially not there. There's accessibility settings and stuff that you can do both on Android and iPhone or iOS devices. Those only do so much, though. There are certain phones that are good. I think it's I've read about a particular Samsung model and tablet that, due to their OLED screen or whatever, the background brightness on them is really dark, so they have really high contrast and they're really good. My stuff's not that good, so I use this red film you see here, Rubylith. They used to use it back in the linotype days for printing, but this film you can cut it into shape and put it over your devices. It's really great, and it lets the red light through, and it keeps out the other colors, and it really deepens the contrast on things. It really makes your devices easier to see. I really like that stuff. Same for your laptop. You can get red screens to go over your laptop, but even better, do something like get a thing like this. If you're going to be out there using your laptop, put it in a box, or they sell these tents for literally to put your laptop in, both for astronomy. Also, believe it or not, for people who are working on the beach and they want to diminish the light shining onto it. You can also use it to keep the light from shining from the device onto others. Key thing here is, if you're out with others, be courteous. Everybody's eyes are out there, and your light affects other people. And don't be lazy. It can be very easy to say, I'm not going to do it. It's better for other folks. It's better for you too. And you'll really see more if you make just a little bit of effort to make all that stuff red. Another key thing is your car. Figure out before you leave home how to turn off your car lights. And a lot of cars, I know it's tough these days. You might have to dig in your manual, but they'll do all sorts of flashing and stuff. When you're at the site, turn off all the lights that you can, both inside and outside the car, because inevitably you're going to forget something. You're going to have to get back in there, and you'll turn its lights on. If for some reason you have to do that, warn others. Or if you have to do a light of any type, warn others so they can cover their eyes. Another thing I've done with my car is, for the little lights on the bottom that I just can't turn off, I've found like that red film you see when you break your tail lights. You can get that red sticky stuff. I put it over the little lights on my doors, and it keeps them red, and it works well. And if anybody wants some, I got a whole roll of it, so I'm happy to share. That brings us to Brown's third law of observing. No matter how well you know your headlamp, if it has a white light, at some time during the night, you will accidentally turn it on. And the first correlate of that is, even if you think no one else can see your computer screen, someone can. At the very least, you can, but most likely other people can too. And the second corollary is saying sorry doesn't allow their eyes to readapt any faster. So really be curious about all these things. All right, now you got out there, you're all prepared, you're set up, you got your car is dark, everything is good to go. So how do you find things? There's multiple ways to find things. I'm going to first talk about probably the one people think about most, including on those telescopes over there, are electronic systems. These can be go-to, where the telescope's got a motor, and you put in an object and go, and it moves around. Or these can be push-to, where it will give you the coordinates and essentially say, go, it will count down as you get closer, in altitude and azimuth. You can have things that have a hand controller like those over there. You can have things that interface with a phone or a tablet, or you can even have things that plug into a computer. Some of these things, like Sky Safari, have great visual interfaces. I use Sky Safari a lot. Key thing, though, is you usually have to find a couple stars, at least 2 stars, often 3, to align these objects. So you have to know something. You have to be able to figure out when it says align to Capella, where Capella is. And if you've got like Stellarium or something like that, that will help you do that. Another key thing is people expect these systems to do everything for them, but they can be harder to use than you might expect. If for some reason things don't work, and this is part of my problem the first couple of years, you have to figure out why they don't work. And often it's going to take some manual methods to debug why they're not working. So they're great, but you have to understand the limitations that they have. Along this line, one thing that people have heard me talk about before is it's an app-like web page. Actually, it's free on your phone. It allows you to use the sensors in the phone, the compass and the accelerometers, to essentially, if you mount the phone on top of the tube of the device, it tracks where you are. You point it to a known object, like a bright star, say, okay, I'm pointing at that. It goes, okay. And then you tell it what you want to go to, and it will navigate around with that little arrow. So like, as you can see here, this arrow is saying, I want to go to, I don't have, it's not showing here what object I selected, but I selected an object that's telling me to go to that direction to get to it. So that's a free way to try out some of these electronic things. I already mentioned Sky Safari. If you get into this, there's so many features in this app. It's worth the money. If you go down this path, you can do things like simulate views. You can set up lists. I've used it to do things like, it shows the Horsehead Nebula here. I had set up the view through my eyepieces, and I could flip the views so it matched what I saw in the telescope, and I was able to match up the star patterns that I saw to help home in on the objects. Very helpful app. So that's all electronics. There are other ways of doing things too. Sort of a classic way is setting circles. To use setting circles, you have to have an equatorial mount, and we're not going to get into that today. In future sessions, we'll talk about what an equatorial mount is. But this is basically, you have to align your telescope with the North Star. And then you set the dials on it to 0. And then you can use coordinates to find objects. This works well. I have a friend who, and I actually have a picture of him with his telescope later on in here. He had a small telescope. He used setting circles, regularly to find objects. But it does take some practice, and it's often difficult to be precise. And the last method I'm going to talk about here is star hopping. And this is probably the most classic way that people use. And you'll really find that no matter what you do, whether it's electronics or the setting circles, you'll probably use some elements of star hopping in whatever you do. For star hopping, you use the finder that you have with your telescope. It can be a finder scope. It can be a tail rad. It can be an easy finder, like the one that's on the top of the small scope over there to the right. Or it can be a red dot finder. That's the typical small little thing that looks like a gun sight with an LED on it that you use as a finder. With that finder, you use a mapping software. It can be Sky Safari, Stellarium, or a Star Atlas with a wire loop. And we'll talk about that more here in a second, to match up what you see in the viewfinder with what you see on the map. And then you use bright stars as guideposts. For the example here, you have the Big Dipper and the Little Dipper, and it's showing you relative to these two stars on the handle where M101 is, Messier 101 is. This does take some practice, but the great advantage is it's a very useful skill, and it's free, and it requires no power. You don't have to worry about the computers working right or anything like that. Maybe you have to make sure your batteries and your finder are good, but that's pretty much it. I mentioned before this book, Turn Left at Orion. This is a really, really good book. It essentially walks you through for Messier objects and other bright objects, step by step, how to find them, using the star hopping method. Highly recommend this book. I mentioned before, you can use a paper star chart, including like from freestarcharts.com and any finder, and use that to find objects. You'll want to know the field of view of your finder, essentially how many degrees it is. The Telrad, a common thing, is got 5 degrees, and I think that's what it is on the quick finder over there. You can also do things like, show here in the image, you can use the Big Dipper to estimate the field of view of your finder. This shows the number of degrees between each of the different stars in the Big Dipper. If you do that and figure out what your view is, you can make a little wire loop that matches up with the scale of your star chart and use that to move around. Match that view. And here's essentially what you do. Like, for example, if I'm going to M101, remember I said it was near the relative to these stars at the end of the handle of the Big Dipper. You can start on one bright star here and then sort of follow the path of the pattern of the stars you see through your viewfinder over till you find it. It's essentially, that's why they call it star hopping, because you're moving from star to star and hopping along. You can do something similar with an electronic thing as well. This is using Sky Safari and using Telrad. You can set up Sky Safari to display your finder's field of view. In this case, I've got it set up showing what the Telrad would look like at that scale. And you can do things to, in this case, move over to the Owl Nebula. You start on this known bright star. You move your telescope up until that star is right essentially at the bottom and relative to these other stars, and with that you should have the other ones, the Owl Nebula over here in the view towards the edge, and then you can move over in that direction to it. Again, it takes practice, but this is essentially the methods you can use called star hopping. Okay. All right, so you found the object now. You're starting to look at it. What do? You start with your lowest magnification eyepiece. In other words, the largest focal length. And again, we'll talk more about that in future lengths, but the key thing to remember is that the higher the number on the eyepiece, it's going to be lower magnification, because the magnification is essentially the ratio of the focal length of the telescope and the focal length of the eyepiece, with the eyepiece being in the denominator. So the bigger that is, the lower the magnification will be. If you're looking at dim objects, you might have to use averted vision. And that's because in your eye, the center of your eyeball is really good at seeing color, but it's not so good at seeing dim light. So these rod cells that are away from the center of your eyeball are more sensitive to light. So if you look off to the side a little bit, you'll be able to see dim things better. Another key thing to keep in mind is if your telescope has mirrors, the view may be reversed, and it's going to depend on the exact telescope, but it's pretty easy to figure this out when you're moving the telescope around, if things are flipped one or both directions or not. Another key thing is, depending on your eyes and your glasses, it may be easier to see with or without your glasses. You'll have to practice a little bit. If you've got astigmatism, it may help to have your glasses on to correct for that. Part of it also, though, depends on the eye relief of the eyepiece. If you have to get your eyeball, the eye relief is how close your eye needs to be to the eyepiece to see the view. If a telescope has, if an eyepiece has low eye relief, that means you got to get your eyeball super close to the eyepiece, and if your glasses are in the way, you can't get close enough. So that might not be an option. So more expensive eyepieces often have a longer focal length. And again, these are all trade-offs that you have to look at. But try it both with and without glasses to see what works for you. The other key thing is that if you're sharing views with someone else, and my eyes are terrible, and people always come up to my telescope, I'll show them something to go up and look and say it's out of focus. Like, oh yeah, sorry, my eyes are terrible. Yeah, make sure you refocus that for you. All right. Now, sorry, I can't help you. It's just the truth. Don't expect this. We're not going to see this. Keep your expectations realistic. Yeah, it'd be great to see all these little moons and circles, and look at the little shadows of the moons on there. You can see shadows of the moons. You really can, but it's not going to be in this great a detail. Here's more realistically what you're going to see. And it's still pretty cool. With your naked eyes, you're going to see things up here. With binoculars, going to be, zoomed in a little bit more, start to see some outlines. With a telescope, depending on the focal length, you'll see the rings. It could be, if it's not, a very good telescope, or if it's just a, not high magnification, or if the conditions aren't good. Conditions are another key thing in all this. If the seeing is good or not good, that's going to affect what you see too. But something like this is actually pretty good. You can see the different bands. You can see the Cassini division there within the rings.
What magnification would you need to see that on a telescope? And good conditions, reasonable.
I don't know off the top of my head. Who somebody have an estimate off the top of their head what that might be?
Oh, like 8-inch scope, like C8 or so, inch mirror, probably about 200 power, maybe 250.
Maybe 200.
max.
Yeah, that's probably about right.
Next to it, yeah, about 8-inch
Okay.
max,
Yeah,
yeah.
I think Eric's about right there. So I guess let me just back up there a second. Yeah, so keep your expectations reasonable. Don't expect this. You're never going to see that. Yeah. Or unless you're doing astrophotography too, right? Which people do, which is part of the reason people do that. And that's another whole thing. Yeah, we're talking about visual astronomy here too. Okay, you found an object. All right, now what do? Stop. Don't just run to the next object. Spend some time with it. I talked about using averted vision. Move your eye around. Sort of look off to the side. Notice what details you can see when you look directly and with averted vision. Try different magnifications. If you put in a higher power eyepiece, what do you see? In some cases you'll see more detail. Depending on the sky conditions, you might zoom in. It just gets to be a bigger, blurry thing. Sometimes you can't help that. If it's a dim object, sometimes actually having lower magnification will help, because essentially the light is more concentrated and you can see it better. Things like, do you see more detail? Do things look brighter or fainter? If you sometimes you'll be looking at like a bright or a large object like a nebula or something like that. Pan around, see what you can see around the area, and look at detail. I got the Ring Nebula here. That center star is 13 something, Nathan. What's I think you told me before, but I know the center star is a good test too to see, can you see that center star in there? There's all sorts of details. Really spend the time looking at things.
So we're seeing our sun in about 5 or 10 billion years.
Yeah. This is another planetary nebula. Notice features and characteristics. Describe to yourself, but also write these things down. What do you see? Look at the shapes. Look at directions. Look at the colors and bands and shading. Look at shadows. You'll see, especially if you look at things like Jupiter. I was looking the other night, and boom, there it was. There was a shadow of one of the moons going across the face. Pretty cool. Even things look like phases. Alan was mentioning Venus. Venus has phases. You'll be able to see a crescent Venus and things like that, depending on the time of year and the relative position of the planets and things like that. If you're not using a mount like that that's motorized and sort of tracking things across the sky, know which way things are moving. That'll give you an idea of the directions in the sky and how everything's going. Write down what you see. A notebook is the best thing. Just write things out in the notebook. Optionally, you can record your observations in an app. Something like Sky Safari allows you to enter notes. But honestly, using just a notebook is the best way to learn and to keep things. Write down sort of things about the session, where you are, what time it is, what the seeing and transparency are like. Are they good or bad? The temperature that's out there, what telescope you're using. When you're looking at a specific object, know, what eyepieces did you use? Did you use any filters? What did you see? Write down those notes. There's a whole subpart of this hobby that involves sketches. People will spend, time at the telescope sketching out exactly what they see. And not something I've done little cruise sketches here and there, but people who really get into this will note that as you start drawing out things, you're focused on the detail and you notice more and more things as you draw that out there. So, spend the time if you can to really focus in on those details. Another key thing is looking at, what works well for you. Like I mentioned, I went through a whole bunch of stuff, and it wasn't really until I started writing down for myself what was working well for me that I figured out what I should do the next time. And that's gets into the other thing. What should I do differently next time? Bring those heavier pants next time. Bring the long underwear, things like that. Bring that second hat. You can do things like you can download little observing guides. This is one from the Astronomical League. They have a whole little setup that will help you do that. You can download those sheets and print them out for yourself. But all you really need is just a notebook. Do things to write down the notes that you have. This is just some examples that some people have of what they saw and what they noticed. All right, spend the night. You're all done. So now to finish up, pack up everything carefully. If you're out there with other folks, really be mindful of them. Use the red light as you're packing up. Don't turn on your headlights in your car until you have to, and warn others before you do. So be careful, get everything in your car. And when you get home, if your equipment's damp, set it out, remove covers so that everything dries out. Recharge those batteries if you got things that take batteries, and repack those bins so you are ready for the next session. All right. So why do all this stuff? Oh, sounds like a lot of effort, but it really can be fun. You start with the naked eye objects. The moon. There's so much stuff on the moon. It's really very cool. The brighter planets. The Pleiades, that star cluster up there, that you can look at and see with your naked eye. It looks really cool with binoculars or a telescope as well. The Andromeda Galaxy. You can see, when you learn where to look, you can see the Andromeda Galaxy with just your eyeball. You can see it with binoculars and any size telescope too. The first time that I realized that, it's like, really? I can see a whole nother galaxy up there? It's pretty cool. Try to go out at least once a month. The new moon is the best time to go out, obviously, because it's going to be dark if you're looking for things other than the moon. Throughout the year, different things will rotate into view with the seasons. Of course, practice makes everything easier. And remember Brown's first law, go out there with whatever you got. It's much better. You're going to learn a lot more and have more fun than if you've got a telescope sitting in the garage. Go to a star party. I already mentioned some of those. I try to post every time I go out to Washington Road. Please come out with me. Al posts these monthly star parties over here at Old Downeyville. We talked earlier about the Plumas Eureka Star Party in July. I already mentioned the Golden State Star Party. You'll just see so much stuff. They have talks in the evenings. They have food. They have giveaways. It's they gave away a smart telescope last year. They had a drawing for it, and they have all sorts of accessories to give away. There's other star parties around the state as well. I put this picture here. This is the friend I mentioned earlier. This is it's a nice telescope. It's a Questar, which is a classic telescope, as folks know, but it's only 3.5 inches, so it's the same size as that small telescope over there. He's another tech guy, a friend of mine from college. When he got his first money from his first good job, he bought that telescope. He used that telescope for 20 years with setting circles. He took it up to the Golden State Star Party. He was finding nebula and all sorts of stuff. You can do a lot with not very much, and you can have a ton of fun. That's part of the reason I put that picture in there. Also, he's just a great friend of mine too. Yeah. All right. Getting to the end, and now we're going to start talking about. We're going to finish this up on the why. Why should you go out? All right. It's very easy to stay home. You can sit there in front of the TV, and you're going to be warm and comfortable and entertained and all that sort of thing. It takes more effort to go out, but you're going to feel a lot more satisfied. You're going to learn. And really, you need to find your own why to get out there. There's a lot of reasons to go out and observe the sky. Part of it's learning. There's a great satisfaction learning new things. There's a sense of accomplishment as you find these things and increase your skills and all that. As you go out with folks, there's camaraderie and friendship. I've got some great friends that I've observed with over the years, and tearing up here a little bit. I got a good friend, I was in high school with, and I'm sure he's going to watch this. So anyway, my friend, appreciate all you've done over the years. And you'll make new friends too. And being out there under the stars with other people is just a great way to get to know folks and really enjoy the company of others. I also love going out by myself. There's just something very peaceful about being out there in the night, with the stars out there, just very regenerating. Beauties, of course, many of these objects are just gorgeous. There's connection to the natural world, or maybe spiritual connection, depending on what your beliefs are. But I always find that just being out there gives perspective on life in the universe. So, with that, Brown's final law observing, it's worth the effort to go out and do all this. So this is the first we're going to do. This is the longest presentation that we're going to do. This was really just the basics to get to get people started. We're going to do other presentations on these different things, and they'll probably be shorter. Maybe we'll combine some. We haven't figured all this out yet. But we want to keep this to be a learning session where people can learn step by step, different things and how to observe. Like I said, there's links. I've got 3 things of links here. I'm not going to make you read them. I will email them out. If you're a member, you're welcome to join tonight. If you haven't joined already, and get on our email list, you can get all of these links. And lastly, go out and observe. If you need help getting started, if you want to show the night sky, contact me. Every time I talk to anybody about the sky, I say, contact me. I'm happy to take anybody out and go out with anybody. So with that, end the presentation. Thank you. Other questions?
Hey, sure, warned us.
Can you use a green laser pointer without destroying your night vision?
People do use green laser pointers. You do need to be careful where you're using those. Some star parties, I should stay over here into the camera. Some star parties specifically prohibit those green laser pointers. They're especially problematic for people who are doing astrophotography.
Yeah.
But if you're out by yourself somewhere, yeah, you can use a green laser pointer.
They are dangerous because they work by generating infrared, and then somehow you get to understand it gets transformed by a crystal into green. But a lot of infrared leaks through, and your eye will not adjust to the infrared, and you can really do damage. So
Don't want to shine at your eye, that's for
Yeah,
sure.
yeah.
Other questions?
That was very thorough, Ron.
Super.
That was very,
All right, thank you.